Hello, everybody. Today, we're going to do this problem about half-life. Here, we are given that the half-life of carbon-14 is 5,600 years. Amazing, isn't it? So this means that in 5,600 years, half or 50% of carbon-14 is present. If a piece of charcoal made from the wood of a tree shows only 63% of the carbon-14 expected in living matter, when did the tree die? Okay, so in 50%, only half of this carbon-14 will be present. In 5,600 years, only half or 50% of the carbon-14 will be present. So here, it says 63% is present, and so it has not reached its half-life yet. So that means the answer should be less than 5,600 years. So to see what that answer is going to be, we're going to apply this formula, A of t equals A sub 0 e to the negative kt, where A of t is the amount present after time t, A sub 0 is the initial amount, k is the decay constant, and t is the time. The first thing that we're going to do is we're going to find k. To do this, we'll start with this formula, A of t equals A sub 0 e to the negative kt. Okay, now we want to know about when the substance is half of its original amount. That is, when will we're dealing with the situation where the carbon-14 is half of its original substance. So that'll be in 5,600 years. So in order to write all this out, A of t is going to be 1/2 A sub 0. So A sub 0 is the initial amount, and 1/2 A sub 0 represents 1/2 of that original amount, which is what we want to deal with in this half-life. So that's why we replaced A of t with 1/2 A sub 0. So again, A sub 0 is the initial amount, and 1/2 A sub 0 represents 1/2 of that original amount. So A of t is equal to 1/2 A sub 0 equals A sub 0 e to the negative kt. Now, we have 1/2 A sub 0 in 5,600 years. So this is the situation when t is equal to 5,600. So let's go ahead and put that in for t. So now we have 1/2 A sub 0 equals A sub 0 e to the negative k times 5,600. Next thing we're going to do is we're going to divide both sides by A sub 0. The A sub 0s will cancel out on both sides. And so we're left with 1/2 is equal to e to the negative k times 5,600. Okay, now we normally put the coefficient in front. So let's go ahead and just rewrite it like that. So we have 5,600. Actually, we have e to the negative 5,600 times k. Now we just have one variable showing, and that variable is k. So let's go ahead and get the k by itself. To do that, we're going to take the ln, or the natural log, of both sides. So we'll have ln of 1/2 equals ln of e to the negative 5,600k. Let's go ahead and bring down 1/2 of ln for now. Equals the ln and e essentially cancels each other out. And so we're left with the exponent, which is negative 5,600k. Now we can readily get the k by itself. So to do that, let's divide both sides by To get the k by itself, let's divide both sides by negative 5,600. All right. Now we can use a calculator to find ln of 1/2 over negative 5,600. I like to use the Desmos calculator at desmos.com/scientific. Let's go ahead and put this in. All right, so that's going to be ln of 1/2. Now 1/2 is the same as 0.5, so we'll put 0.5 in there, and then divide by negative 5,600. All right, now after simplification, we get 1.23776282 times 10 to the negative 4. So this answer is given in scientific notation. Well, let's rewrite this in normal everyday notation. To do that, notice that the exponent is negative 4, so that means we'll move the decimal point 4 places to the left. So now here's the decimal point. So this actually is equal to 0.30 and then 123776282. So this is what our K is. So K is equal to 0.00012377682. So this is how fast the decay is changing, which is very slow because 0.00012377682 is a very small number. All right, now this number will help us find how much. So now this number will help us find how long it will take for the carbon-14 to be 63% of its original state. To do that, we'll go back to that formula. A of t is equal to a sub 0 e to the negative kt. All right, now A of t is what we're trying to find. Actually, we already have it. We're talking about when A of t is actually equal to 0.63 a sub 0. All right, so we want to know now, when will the carbon-14 be 63% of its original state? And this is when A of t is equal to 0.63 a sub 0 equals a sub 0 e to the negative. Now we know what k is, so let's go ahead and put k. Let's put the number in for k that we just found. So that'll be e to the negative 0.0001237.76282 times t. So now we have 0.63 a sub 0 equals a sub 0 e to the negative 0.0001237776282t. All right, now just like we did before, we can divide both sides by a sub 0 to get rid of all the a sub 0s. So let's go ahead and do that now. All right, a sub 0s go away on both sides. Then we're left with 0.63 equals e to the negative 0.00012376282t. Now we just have one variable showing, which is the t. So now we can get the t by itself. To do that, we'll take the ln of both sides. So anytime you have a variable in the exponent, we can always take the log of both sides to bring that variable down so that we can get it by itself later. So let's take the ln of both sides. And we're doing ln because e is related to the ln. So ln of 0.63 is equal to ln of e to the 0.0001237 76282t. 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 Okay, now we'll bring down the ln of 0.63. The ln and e will cancel each other out again. That leaves us with the exponent, which is negative 0.0001237 And now we'll divide both sides by that number. All right, now that number will cancel out on this right-hand side. So now it boils down to simplifying ln of 0.63 over negative 0.00012377682. Let's go ahead and go back to Desmos on that one. All right, here we are. It says 3,732.827,098. Okay, let's suppose we want to round that to the nearest whole number. Okay, let's round that to the nearest whole number year, and let's check it again. So we have 3,732.827,098, and to the nearest whole number year, that'll be 3,733. And to get that, we can just go ahead and just put round and put everything in parentheses, and we get indeed 3,733. Well, let's see if that makes sense. So earlier we said that the half-life is 5,600 years, and we're talking about when 63% is present, which is not quite yet 50% being present. And so the time that the tree died should have been less than 5,600 years. And we do get an answer that's 3,733, which is less than 5,600. So that seems to be the right answer. If we got more than 5,600, then something was done wrong. But in this case, since we got less than 5,600, this answer seems to make sense. So 3,733 years. All right. Now here we have another half-life problem, but we'll do that in another video. So in the meantime, that was how you do a half-life problem when you want to find how long it takes for some substance to be some fraction of its original substance.